Hello there.
Shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. We're the ground beneath your feet. We're the whisper in the tree. Do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution.
Damn, son. Damn, son. Damn, son. Damn,
Good evening and welcome everybody, it's Obi-Wan Pez for in Simplex Pachinko. I think tonight, see how things go, but maybe we will do some mathy type stuff, more so than looking at papers tonight, just because I'm getting kind of antsy and need to come up with something cool. Need to keep my mind distracted, let's be honest. So we're going to try to do something cool. No idea what. Hope everybody's at least been somewhat decent. Hey Bit, how you doing? Your cats are keeping you floofed. Nice. Now, one of my old colleagues always had trouble grading because his cat would always be crawling all over him. So. Yes, they are excellent paperweights. Oops. All right. Bit, you got anything you want to see tonight? Otherwise, I am likely to just jump into, I don't know, differential equations? Pre-calc? Well, good luck. I don't know it. Not really. Anyway. Let's see. Hey Stookie. I don't really know. I'm just getting agitated, so I didn't think reading papers was going to be the most effective use of my attention span. It's not good. That's an interesting question, right? We do have probability and statistics that we can talk about. And I did, in fact, start working on a small program for yeah. Did start working on a small program for who's it's Python to try and study a particular outcome of dice rolls. So I don't know, we might jump into a little bit of everything. Cryptanalysis. Nice. So at times like this, I could really use a second camera. Nobody tell my wife. I have a dice tray, which would be extremely useful to have here. PTZ, okay. So I could like pick up my hands as I'm working. I know I did that for origami stream. One sec. That was kind of fun. Yeah, they're getting a blind house tour. There we go. Okay, there we go. Coming back. Yeah, you get a sense for the house based on the acoustics, right? That's how it works. Pan tilt zoom. Okay. Yeah. They don't track a specific target, right? Like you have to manually control stuff. Right, so we've got some fun dice. First are the non-platonic. Oh, okay. Yep. We have the 24 and 60, which are good for randomizing times. So if you specifically want to do something with hurt, I'm sure this is perfectly acceptable. Eh. Yeah. Getting closer, I think. Yeah. So if you wanted to randomize a particular time, that is a 2116. So. And then we have the D12. This is the rhombic dodecahedron. So not really weird or anything, just kind of fun shaped. We have the pointless D4, which when you roll it actually shows up with the number on the opposite side of the large face that it lands on. So you can actually see what it's supposed to be on, instead of the old caltrop D4s having to read around the bottom or having to read all the way around the top. And then we have the truncated, is it just 8? Yeah. Truncated octahedron, which has these square faces, as well as the, what are those? Those are hexagonal, but they're slightly off. They're not regular hexagons. At least, it doesn't look like it. Well, they might be. They just kind of looked bigger for some reason. Nice. Got an 8. So those are the non-platonic solids dice. Those came from the Dice Lab. I believe those came essentially from the same... might be the Math Skier group who are from like Matt Parker and a lot of the other number file people. This one is Math Skier. So, this is the non-transitive grime dice. They come in number of colors. There we go, 5. So these come in 5 colors. They're pretty cool because they are non-transitive. So even if, you know, yellow beats purple, purple beats blue, blue beats green, and green beats red, which is not true in this case, but actually, you know what? Let's just literally put them in order, because they all landed on a different face. I do believe that that's actually 100% what happens. I'm pretty sure none of them have a duplicate face to any other die. Somebody might say, well, how could that possibly be? Well, that's because they don't have standard die faces. So we do have 2, 3, 4, 5, and 6 on the blue, yellow, red, green, and purple, respectively. But that also says that the purple one also has a 1. The 5 also has a 0. The 4 also has a 9. The 3 also has an 8. And the 2 also has a 7. So, if 2 people roll any 2 differently colored dice, they will never tie. And they have a certain probability of always beating another one of the dice. So this ended up being a game where James was just like, hey, roll for it. And somebody would be like, all right, sure. So they pick, you know, the one that's got the 9s and the 4s on it all over the place. So they're like, yeah, I want that die. And then James would say to himself, okay, so I'm going to pick purple. And on average, if we were to throw these 2 dice, then purple will win most of the time. Because all of the sides of the purple die, with the exception of... Oops, nope. There are 3. There are... wait. Okay, yep. There are 4 6s and 2 2s. Or, sorry, 2 1s. So the probability of throwing either a 6 or a 1 are then going to be respectively 2 out of 6 and nope, wow, boy, 4 out of 6 and 2 out of 6. And then with the red die, it is 1 out of 6 is going to be 9, and 5 out of 6 is going to be a 4. So we could do some like elementary probability here to see how that all works. Right, so it is, let's see, he also, yeah. he also worked out a nice, like, mnemonic in order to figure this all out. So James said if you start with red, blue, and olive, specifically olive, not green, olive. Hey Afru, how's it going? Right, so red has a 4 in 6 chance of landing a 4. No, that is wrong. It's a 5, isn't it? Yes. 5 in 6 chance of landing a 4. And a 1 in 6 chance of landing a 9. Blue has a 3 in 3 chance, 3 out of 6 and 3 out of 6, and landing either a 2 or a 7. We're always going to put the lower one, lower number in the higher position. Let's see. Olive has a, nope, 1 in 6 chance of landing a 0 and a 5 in 6 chance of landing a 5. The Royal Base. I'm going ... in my head. Oh. Yeah, the trip down to Lakenheath was uneventful, but good. I got stocked up on coffee on the way down and made sure that I was... yeah. Made sure that I was wide awake for the journey. It was about 3.5 hours or so, which wasn't too bad. That's about my limit for driving, is right around 4 hours. I start, like, not quite hallucinating, but it gets pretty bad. Like, the road starts blurring in my eyes. I'm just like, ugh. Okay. So let's go with, like, expected value. Right, we get a 5, 6 of getting a 4 plus a 1, 6 of getting a 9, which is going to be a 29, 6 as the expected value. So this is a 4.56. 8.3 repeated. All right, blue. We have a 3 in 6 chance of getting a 2 and a 3 in 6 chance of getting a 7. Now, it doesn't really matter. We could have done this in terms of just 1/2 for each of these because reduced fractions, and they're going to be the same in this case. I only just didn't do it before because the 5, 6 could not be simplified, and then it turned out we needed the 6 anyway, so why not just do it all at the end and not worry about it. So here we have a 6 over 6, and this is a 21 over 6, so that's 27 over 6. Which you can tell is slightly less. Oops, less. than the one that comes before it. Right, ever so slightly. Which is a 9/2, which is a 4.5 expected value. Right, and then we have, again, this is going to be a 25/6 here. I could just tell that immediately because we're going to have a 0 in that position. So, makes that one super easy. 25/6 is going to be a third less than a half, right? So, yeah, 4 and 1/6, right? Well, okay, it's exact because I'm doing the I'm doing an infinite. So this is 4.1, oops, 1 with a 6 repeated. Boo. Now, interestingly enough, as Good evening, Zach. How's it going? Hope all is well on your side. So interestingly enough, right, if we just look at the red, blue, and olive dice, we can see that based on the expected value, red is going to beat blue is going to beat olive. So, sorry, from your perspective, that way. I'm getting better at the perspective thing. So it looks like, yep, that would be that way. Red should always beat blue, which should always beat olive, which, in theory, red should also then beat olive, like, every single time, because the expected value is so much higher. Good evening and welcome everybody from Zach's channel. My name's Obi-Wan Pez. This is N-Simplex Pachinko. If it helps, you can think of this guy running the show. Hello. Oh, yes. Hello there. God. Missed that opportunity. At any rate, yep, we're going to be doing a little bit of talking about probability and statistics with dice, because I just needed a change from stuff, and you know, mental health is important, and today it's not super. I'm okay, but you know. The news. Is not in its best form at the moment. Sorry. I have a hair in my mouth. Okay, well. Good times. So... well, hopefully more dice than ice, but, Earendel. That was not the plan when I came in. The plan was just, let's not talk about papers today because I'm gonna go insane. Yep. So anyway, we have our dice. These are Grime non-transitive dice, which are the ones that James Grime put out. He's been on Numberphile a lot. I believe his channel is Singing Banana. and he does a bunch of work with Numberphile, and he also helps to run Maths Gear, which is like, I think, a partnership of a bunch of Oxbridge mathematicians who just, like, you know, made some cool stuff and then put it online for people to buy. So we were talking about the non-transitive dice and what the expected values show us. So with the expected value, it seems like red should always beat blue, should always beat olive, or at least on average should, based on the expected value. But interestingly enough, if you look at the individual numbers that are rolled, right, it turns out that this actually beats red. Olive beats red more often than not. Why? Well, because 5/6 of the time, red rolls a 4. Right, which has now a probability of, a branching probability of only beating olive 1/6 of the time when olive rolls the 0. But the rest of the 5/6 of the time, red's going to lose. Then when red rolls its 9, it's dominating. So here we just get a 1, because it will always win if it rolls the 9. So then we have our probability of red winning. Is going to be 1/6 times 1 from the first one. And in our branching probability from the first set up here, we have 5/6 times 1/6, which is going to be 5/36. So then this is going to be 6/36 plus 5/36, which is 11/36 of the time red is going to win, which then puts, again, olive wins 25 out of 36 of the times. So there is an edge, right? That eventually olive is going to lose to red, which seems like it should be weird based on the expected value. Okay. Then right, okay. It was not purple. So yellow and magenta are then added. And this ends up creating a weird diagram here, which shows you what everything is going to beat. So magenta is going to beat red, red's going to beat blue, blue's going to beat green, green's going to beat yellow, yellow's going to beat magenta. Blue is going to beat magenta, which beats green, which beats red, which beats yellow, which beats blue. Yes, I'm sorry, olive. And then if somebody's like, okay, tell you what, I then would like to pick first. So if we went this way, they say, okay, how about I pick second? What you can do is say, okay, no problem. Let's roll 2 dice. So go ahead. I will take red, and then they'll be like, okay, so I know that red is going to get beaten by olive. So now we're going to roll 2 at once and see what happens. And so when you roll 2 at once, we have our red, which has, again, each of them has 5, right? Yes. Each of them has, again, 5, 6 to get a 4, and 1, 6 to get a 9. But now we're rolling 2 of them, so we get our branching probabilities going. So 5/6 of the time, it also rolls a 4, and 1/6 of the time, it'll roll a 9. And again, 5/6 of the time, it's going to roll a 4. 1/6 of the time, it's going to roll a 9. Okay? So then if we look at the expected value of this, this is going to end up being 4 times 5/6 times... wait a minute, hang on. Is that how this works? I don't think that's how this works. No, okay, that's gonna work. Okay. For our expected value. Alright. Plus 9 by 1/6 by 5/6 by 4 plus, shift down, 4 by 5/6 by 1/6 by 9 plus 9 by 1/6 by 1/6 by 9. Alright, so I don't need that. Have it on standby. Right, so here we get 20 over 6 times 20 over 6 is going to be 400 over 36. Plus, this is going to be a 20 times 9 is 180 over 36. And that again. And then 81 over 36. It's going to be 4, 5, 6, 7, 60, 8, 41. Okay, that one I'll take a calculator. 23, so somehow I messed that up. Is it a plus in between? Because we're adding the 2 values. Okay, yep. That must be it. But, oh, no. Not that entirely. Right. Okay. Because now we have to think. Okay. Yep. So this one here is going to be a condition, or not conditional, but this one's going to be another this same 5/6 multiplied by that stuff as well. Then this one here is going to also be multiplied by that 1/6 as well. So combined, we're just going to get a 9 plus 1/6 for the two of those. Okay, and then the same thing's going to happen with the 4 times 5/6, where we're going to get two of them, which have themselves also been multiplied by 5/6 and 1/6. So we're only going to get one of them in total to add together. Alright, we'll see how this goes. Alright, so this is going to be a 29, 69, and 18 is 87 over 6. I think, one sec, 14.5. That at least seems more reasonable. So I was going for the expected value of what happens when you roll 2 red dice, which are 5/6 of the faces are 4s, and 1/6 of the faces is a 9. Like I said, these are non-transitive dice, so cursed is also probably acceptable. So this includes a 1 in 36 chance of rolling 18. That's also another thing to do, right? So how many out of 36 rolls right? There's going to be one that is an 18. There's going to be 5, 10 that are going to be 13. There are going to be – 25, right? That are going to be 8. Is that it? Yes. Okay. Okay, so this is 18, 130 is going to be 148. Huh. Maybe I wasn't that wrong before. 200. Okay, no. It's 348 over 36. Oh dear. It's 9.6 repeated. Okay. I actually like that number better. Because there's going to be a lot of 8s that are rolled. And then, like, 13 is not a rarity, but it happens a lot less. No, I can't do that. Wait. Hang on. No, that's right. Okay. Because again, it's going to be 8 times 25 over 36. 10 over 36 times your 13, and 1 over 36 times your 18. Okay. Yeah. So 9 2/3. This is all just wrong up here. Just clear that out. Nope, nope, nope. This is what real math looks like. Woo! Lots of mistakes. Okay. So our expected value is going to be 9 2/3 on red. Then when we switch to olive, right, these are going to be 5 5s and 1 0. So of your 36 possible rolls, right, this is going to be 1 that's just a 0. I think this makes that 10 again. Yeah. There we go. Yep. Which are going to be 25 or just going to be 10s. So we roll 2 5s. 10 are going to be 5s. And 1 is going to be a 0. So then that's going to be a 0 plus 50 plus 250 is 300 over 360. So, no, 36. Wow. 300 over 36. It's going to give us an expected value of 8.3 repeated, which is certainly lower than our red. However, if we look at the individual rolls, the problem is again that you're averaging in big numbers which don't actually count for anything. Okay, so we've got a 136 probability of hitting an 18, which is going to be greater than all possible rolls on the right. We have a 10 in 36 chance of getting 13, which is also dominating all rolls on the other side. And then we have a 25 in 36 chance of getting an 8, which is going to be greater than getting an 8 is going to be 11 out of 36. Which are either 0s or 5s. Alright, the other 25, 36 on this side are going to be the winners against only the 25 out of 36 on this side, which gets us the 8s. This one was, again, a 10. No, I guess we don't need that. So in this case, we could see that, yeah, red's going to win by both of those. Whereas up here, we saw that when you roll a single die, the olive is going to beat the red. By looking at not at the expected value, but rather by looking at the individual probabilities of what's actually going on for any particular roll. So when you add 2 dice, or if you add a second die, then like almost all of the domination arrows switch direction. So the only thing that, actually that's not true. Sorry, the cycle will stay the same, or the cycle will change its order. So olive blue will beat red, will beat magenta, will beat yellow, will beat olive. However, the internal cycle is approximately the same, with the exception of green and red coming out to very close probabilities, allegedly. If we add them all up, what was the... Okay, so it was a 1/36 definitely win, a 10/36 definitely win, and a 25/36 times 11/36 in order to win here. Or if we go the other way, this is going to be a 625ths out of 36 squared, 900 and 360. It's going to be 1260, 1296. Well, the trick is that James Grime knows exactly who's going to win every single time, because he knows the appropriate way to make it work. Yeah, so this is a 625 out of 1296 is approximately 48.225% winning probability if you chose, well, probably you would have chosen red and said, let's roll 2. I think he also cheated, was that he said, yeah, go ahead, why don't you pick? And then whichever one, or no, he picks, right, so the opponent says, no, you pick first, or let's just swap dice. And then after both of you have your colors, that's when he was like, yeah, sure, let's roll 2 dice now and see what happens. So, totally changing the rules of the game, and like most people would just be like, well, yeah, that doesn't change anything, sure, whatever. But they being mathematicians, you know, and I'm sure the rest of his people at Oxford now don't put up with that. Just like, nah, I know you too well. Aren't they named after you? Right, so this is a 275 out of 1296. I mean, I could just subtract, but why not? do it the fun way, this is an 11 out of 36, which then times 11 times 36 is going to be a 396. That is right. 671. Yeah. All right, 671, 71 out of 1296. It's going to be a, and yes, I know. Could have just done the complement of that one, it's fine. 51.775 approximate percentage probability. Right, so you choose red and say 2 dice. We're going to do 2 dice. So this one's close enough to 50-50 that he was just like, yeah, you know what, it's probably not even worth it to like jeopardize your friendship or whatever. Not really. It's probably close enough to 50-50 that like you're not going to get an obvious edge by playing red and olive. So those are the Grime non-transitive dice, hashtag not sponsored. Over on Math's Gear, if you're interested, these are the same dice that are seen on Numberphile, as well as, I believe, like I said, the Singing Banana YouTube channel hosted by James Grime. Alright, so then here's the fun one, right? We're going to do sort of like in theory what's going to happen. Need my 8. Close enough. It's easily readable, that's really the point here. And my 4. Yep, there we go. Okay, so 20, 10, 12. We need a 12. There it is. 10, 8, 6, 4. Cool. So we can do experiment now. How much time we got? Right, it's about 5 minutes to ad break. So those of you who have your platonic solid dice, i.e. those that do D&D, etc., any of your TTRPGs, I have an experiment we can all collect data together. Woo! Ads are going to start in 5 minutes, so perfect timing. What's going to happen is I'm going to ask if you would start with a D20. And what I want is for everybody to roll the D20, keeping track of the number of rolls you've made. And you could do like the number of rolls at each stage, just to make it easy. Until you either get a 2 or a 1. And once you get a 2 or a 1, you're going to then substitute for the next size down. So start with 20, go to 12, 10, 8, 6, and 4. So we will... We call this the roll down method, starting from a d20 and then working out from there. So, and there's a 1, 2, 3, 4, 5. Okay, so that's 5. One, 2. Oh no. Switch for it. Oops. That was actually a 12, so we'll just shift all these over one block and then shift the 2 back. And that was the 12. What was that one? Yay. Oh, that doesn't count. 3, 4, 5. One. Oh no. Alright, so this is going to be a 10, 13, 14, 15. Okay, so I will describe what this is all about when we get back. So if anybody wants to take a stretch break, get up, walk around, do all that good stuff, we'll be back in 3 minutes, and we shall discuss precisely why I'm doing this. It's good times. Alright, see you in 3. Thanks for coming. this thing. That is the that is my glove that I use for the who's it tablet, which currently appears to be flipping you off. So actually, that was the pinky. It's all good. That reasonable? Yeah, okay. And then for us, Jobby always was like kind of the generic word for a thingy. And then, like, one of my teachers had it for a specific thing, and I don't remember what it was. You could probably tell me what yours was. And it could be the same. Kiddo. Yes, this was totally the other reason why I did close cam instead of... Not really. Hashtag not sponsored. Alright, we're getting better slowly. You know what? Alright, fair enough. That is not what my elementary school teacher meant by that. Hey, Famished. Sorry about that. 10 degrees. Whoa. It's dropping to about 0 here, but that's Celsius. Alright. Let's drop again. No. Alright. If anybody else got some data, let me know what you got. So I had 5, 2, 1, 5, oops, 5, 1, 1. We'll go like that. So there are 6 dice in total that you can start working down with, rolling down. So we start with the d20, and then you roll until you get a 2 or a 1. And then, yeah, and then move down to the d12 until you get a 2 or a 1. Move down to the 10 until you get a 2 or a 1. Move down to the 8, move down to the 6, move down to the 4. Once you get a 1 or a 2 on the d4, that's it, game over. And tell me the total number of rolls that you made. So if anybody did this, that's great. If not, I mean, I'm going to collect some more data, so... if you yourself do not have a set of platonic dice, you know, don't worry about it. Alright, that was not near a 1 or a 2, so we'll just roll again. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, getting real lucky on this one, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, oh man, 49, 50, this is why I don't use d20s, 51, 52, 53. Whoa. Alright, D12, 1. That's just the way, isn't it? One, two, two. One. Damn. One, two. One, two. Right, so outlier. 750, 59, 61. So anyway, I am GMing a group through Titan's Grave, the Ashes of Volcana, which is the Geek and Sundry show that Will Wheaton did with like Hank Green, Alison Haislip, Yuri Lowenthal, and Laura Bailey. And so the 4 of them were subjected to this brand new module for Fantasy Age. Fantasy Age is kind of like the D6 only version of D&D, and then of course you can do whatever you want with it. It turned out that I believe Will's son Ryan was like primary writer on this. Could be wrong, but it was kind of like his project. And then Will helped elevate it by, you know, giving it love and attention, and having them do a playthrough of like the main story in on Geek and Sundry. So it did really well for, you know, for quite a while there, and then they were wondering, like, you know, is it going to come back for a second season? And that's about when Geek and Sundry pivoted and started like Legendary Entertainment, I think, started kind of chucking people out, and they were like, okay, well, guess we're not going to do that. And I don't know if Will has retained the rights, or Ryan has retained the rights for it, but I don't know. I'd like to see it. But in the meantime, I have developed a starting and then a BBEG for the full campaign of it. And so my players right now are going through it. This is the second group that I've had run. We also I did one back in Maryland with 6 players, I think, which was kind of bonkers. But I also sort of had a beginning, but I didn't really have an end to it. So they ended up going and fighting the evil prophet lady, and then she just kind of they knock her down. She becomes like a disembodied voice and is like, ha ha ha, you can't defeat me. And then I will be reborn, blah blah blah, disappears. So then my players are like, okay, so what exactly are we doing? And they're like, okay, well, we're gonna try and figure out what's going on. Let's go to the next town over. So they went to the next town over, and it was like I was just constantly coming up with excuses for them to do things, but it wasn't it was a lot more free form than I needed it to be. Fantasy Age runs a 3d6 system, and so you end up with 2 dice of one color and 1 die of a third. The die of the off color is your dragon die or the stunt die, and if you end up getting doubles, so this has a 663 for example, if a 15 would pass whatever test it is that you're doing, plus any skills that you have in your on your character sheet, if that roll beats whatever the target number is, then you also get whatever it says on the dragon die in terms of the number of stunt points that you can do. So in this case, I would have 6 stunt points to do whatever I want with. There are some suggestions for stunts that are on the GM screen and other things like that. So it's kind of interesting. If you're doing combat, it's pretty obvious. You're just going to do more damage. In some cases, you get to skirmish or knock them around or knock them prone, disarm, that kind of thing. So, Fantasy Age is kind of interesting in that, again, you're mostly, or realistically, you're only working with D6s the entire game. Occasionally it says D3, in which case you take your number and then round up. Have it and round up. But I have been kind of injecting my version of Titan's Grave with other gaming systems as well. So, for instance, my cleric in this thing, I said, okay, your first aid kit starts with a D10 and you're going to do roll down. So we would have, according to this, this first set here was 5, 6, 7, 8. He would have 8 uses of it before it is exhausted. And then this one here would have 2, 4, 6, 7. So this one has 7 uses of it before it's exhausted. And then you have to go and purchase items. I think the recommendation is that you always have a 50-50 shot at least of success or failure in terms of the roll down. So that's why I said, okay, if we do, a 4, then, if we're going to roll down to D4 and then it's exhausted, then rolling a 2 or a 1 on any die should be considered a failure. If we want to do the least amount of rules, lawyering, and whatever else we're doing. D12 really hates me today. That's 4 on that one. On that one. And 3 on that one. Let's also just for fun here. Alright, 6, 7, 8. 2, that's 7. And this is going to be 19, 20, 6, 29. Whereas this is going to be a 9, and 6 is 15. I'd also done a little bit of an attempt. Uh-oh. Is it? Oh, okay. Yep. I also wanted to look at this with PyCharm. What do we got? All right, let's give you the ability to at least see my errors here. Yeah, I also did this one using the sanction rules, which was if it's anything that is less than 4. So a 4 is considered a success. A 1, 2, or 3 will be considered failure unless it's only a 2-sided die, i.e. die flip or coin flip, at which point you have to have a 1 or 2 only. I don't particularly like that. I don't particularly like that as it is, just because I also don't really know what I'm doing in terms of trying to get a frequency graph. And then I was also like, well, where do I call for creating the variable? And then make sure that, what is it? Ah, yeah, right. Mm-hmm. No, not int. Wait. Gotcha. Okay. If anybody else wants in, let me know. So I don't know how to make a frequency graph within Python. Standard histogram. And I don't know how to I guess like where to call it, what variables to bring back, that sort of stuff. And then how to update it, like continually update it as we go through. That's probably... Alright, so that's already been done on the other side, so I can get rid of that now. Right, well, side is greater than or equal to 2. Alright, so D sums is going to be the die sums. Right, so this is not going to do what I want it to. I mean, no surprise, really. Okay, so I think I've done something like this, which was like side equals 12 just for now, and then say run this. Okay. That worked. That wasn't supposed to happen. It did. Okay. Simplest way to use plot histogram is to use a 1D array of data. Okay. 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 So what we really want is on roll down to be able to keep track of every single one. So we want like yeah. We need all this in the other one. Alright, I'm going to want a probably list of zeros. That is going to be the size of the number of sides. Divided by 2. Because we're going to cut 2 off every time. So that's going to mean we want side over 2. Oh, right, it's not defined yet. Hey. What is the issue? Unexpected type float. I mean, supports index. Hey, Sticky. It is complaining because side over 2 is a float and not a supports index or one of these other things. Any shape T. So, long story short, yes. I don't necessarily understand the nuance of the other stuff, but I mean, it could be all I need to do is do int side over 2. Seems like it. Mm-hmm. So, like, can I do something like this and say that the so, like, I'm gonna want N to be the 0th position. So I want this to be like nth position of dsums. Is this what it does? B plus equals dsums n. That's going to complain. Oh, right, because we only have to... That's no. Plus equals 1. Oi. I need it to actually do that up here. No. Sorry, AI, you don't understand me. To be fair, it probably is more ingenious than I was trying to make this. Because it sees sums, and it's like, oh boy, you're trying to sum up all the dice. That's not what I'm actually trying to do, but I can see where you get that. And then here, when we... yes, actually. When we take away from the side, it's going to move down to the next position in dsums. So sort of, Zach. I'm trying to... Actually, it's in chat. I'm trying to get, essentially, the same thing that I typed in. Right, it's only like 5 messages up, so... I'm trying to get something that looks like that. Why is that up there? Ew, gross. That's really messed up. So yeah, I'm trying to get something that looks like this. This actually has different parameters than the one I'm actually trying to do, but it doesn't matter. Right, something that looks, roughly speaking, like that, which is going to be the number of rolls that we did at each number of sides of dice. So, yeah, see also the thing we did earlier. Made a table, right. I is going to be just the total number of dice rolls at all. N is going to be the number of dice rolls, no, N is going to be the position. And the dsums at n is going to be the number of dice rolls at that position. So based on the number of sides that we have. And then, do we also want a line break? Oh, right. And like get me the vector at the end. right? So we add 1 to the position and move over every time that we're doing something. And then once we have only 2 sides, then it doesn't matter. Right, we don't need to move anymore. We've already done our roll at that particular value. Here, that's just iterating the number of rolls we've had at all. And I guess that could go up there too, but it doesn't matter because I is not called in the if block. And does anybody have experience with making histograms on Python? So that's going to be kind of the next thing.
It's the calm before the storm. Things aren't as they were before.
That's fair.
Did you think you could keep us out? Shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing.
So yes, and then I shorten it to just PLT. And so we're doing plt.hist. And then normally this is just the one-dimensional string that you throw in with all of the numbers you want. Number of bins is not going to be 11. Number of bins is going to be a linear space.
With the ground beneath your feet, with a whisper in the trees. Do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now.
It starts at 2, goes to... Ugh. Right. Sides. And then goes to... granted, I have to call those in from the other side, not sides. And that was min, max, number, I think.
But we're not back in town, know what we're doing.
I think it goes like that.
Change is evolution. Words to shake the ground, you're feeling moving. With the revolution.
20 evenly spaced values between -5 and 5 makes NP length space, yeah. Pass this array to the bins parameter of plot hist. Okay. And I will attempt to throw this other stuff in there, so see how it goes. Go. That seems to maybe need to go before the other one. No. Okay. We'll see how it goes. At any rate, we're about to hit an ad break, so feel free to get up and stretch and do all that good stuff. And I will be right here waiting for this, and then we'll do maybe a little Tai Chi break or something. We'll see how it goes. Or, hear me out. Do something psychotic. Like, make the roll down call in here. And then just have it use roll down. For that many trials. Oh, goodness. That'll be data J. I. It's just equal to I, that's all I want. I just want data to be... So it does need to be 0. Yeah. Okay, and then we need data to be initialized. Ugh. Data equals NP0s of M. Yeah, actually. Alright, good guess that you like you understand what I'm talking about there. I say understand. Morning, right, frequency graph. So we're not really using this. Okay, we need not dsums. This is going to be roll down dot data. Okay, that looks better. It's not going to work yet, but nonetheless. This is roll down dot side. Nice. Okay. So do I just go with that? Seems to have no effect. Okay, cool. How do you run? Is it just .py? No. That's not what I meant. And there's no run statement, right? No, you can't do that. What are you thinking? Okay, so we run this first. Number of sides, let's go with 10. Number of trials, 100. Oh, boo. Okay, so this failed spectacularly, even if the rest of it worked alright. Did they all roll 1? That doesn't make any sense. Okay, so we do this and we say roll equals np.seal np.random integers 1 comma side, which is already 12. Oh, come on now. Why? I want you to roll a random number between 1 and 12. Why would I want it to be 1 and 13? No. Oh. It's not this. It's rand int. Just rand int, really? Rand int not defined. Cool. So if I did np okay. I guess I don't understand what function deprecation is, but that's fine. Okay, number of sides, we'll go with 12. Number of trials, 100. You are coming back with exactly the same number every single time. I don't believe you. Oh, there we go. Ah. Okay. So this, in theory, should belong up here. Okay, let's try that again. Okay, almost. So that is the stepped through for one trial. And then data of J. We reset every time. Oh. Oh. Does that need to be here? No. That would need to be before. We are not. Thank you. I guess that one doesn't even matter then. Okay. Try again. Jerks. 12 sides. 100 trials. Nope. That doesn't have the... Okay. Right. So 12, 10, 8, 6, 4, 2. Should also be doing that then. Wait. Hang on. if side is 2 and roll is less than 3. So that is technically going to be every roll. So we want it to be specifically less than 2. And then that's going to end everything. Ah. So is this meant to be printed after? Yeah, this is meant to be printed afterward. Nope. Man. Oh, is it exclusive? Is that what I was yelling about earlier? Okay, so this is at least correct. Ah, hey, that's not right. This got a 9 and then it rolled down. I don't want it to roll down on a 9. Side is greater than 2. And roll is less than 4. So that one should be just fine. Why? That's what I'm trying to figure out. Is it rolling just a 1 every single time? Default int is low, and if you want a high, you have to add it. Mm. I mean... Now hang on a sec. If I want... different upper and lower bounds. Okay, don't want that. Okay, so it's like specifically saying here between 0 and 4 inclusive, we just put 5. So it seems like, right, we just put the high value by itself if that's what we want. But we do want it to be between 1. We don't need this ceiling, first of all. But this does mean that we can say, instead of doing all this nonsense, we can say that we want side to be the high, and then we just add 1 to it in the end. So it'll be from 0 to the number of sides minus 1, and then we add 1. This is kind of ridiculous, but how's it going, Famished? That's ridiculous. Alright, let's see if this did a horrible number of things right now. You know what, just do 10. Nope. Alright, roll a 7, and it shouldn't roll down to a 10. Again. It's just automatically... Oh, God, what is it doing? Drinking coffee, nice. I have my red tea. It's pretty typical for this time of year. I mean, if you're not drinking coffee for fun, you need better coffee. Okay, so what is this doing? So I want roll to be random int up to the number of sides, and then add 1. And it tells me what side is because I told it to print it right after it. So give me what side is. It spits out 12. And then it gave me the roll, which is 7. So if side is greater than 2, true. What's and? Is it just literally the word and? Why did I think it was an ampersand? That's ridiculous. No wonder it didn't work. Jeez. Oh my god. Okay. We'll worry about that in a minute. 6, 6, 3. These are all on 12, which is true. And then my face is in the way. Cool. You all should probably be able to see this. Oh, you know what? We're not using like any of that room over there. So we'll go like this. That'd be alright. Okay, so we said that this is going to be 6 and then 6 and then 3. Those are all on a d12. Then, because it's less than or equal to 4, it rolls down, and we get now a 9 on a 10 die. We get a 5 on a 10, we get a 6 on a 10, we get a 1 on a 10. That causes us to roll down again. Now it's going to be on an 8-sided die. 5 to 8, 7 to 8, 7 on an 8, 8 on an 8, 2 on an 8. That's under the limit. So that knocks us down to a d6. We get a 3 on a d6 and knocks us down again to a d4. We get a 4. And then we get a 1. And then this tells us we get 3, and then 4, and then 4, 1, 2. Thank you for the follow. Okay, 3, 4, 4, 1, 2. And that's supposed to have a 2-sided die as well. Okay. That is then supposed to record the number of this is going to be potentially awful, but we'll see how it goes. We gotta clear dsums every time, don't we? Or put n back to 0, I guess. That's all we really have to do. And then that will work itself out nicely. What happened? Right. Yes. Yeah. And reset n back to 0 when we do that, and then it's just going to write over itself again and again and again. Oh no, that's okay. Yeah, because it's always the same dice. So it's just going to rewrite and rewrite and rewrite. Yeah, that's fine. Next question. How did logical equivalence? Did I just pseudocode this crap again? No. Oh, yep, there we go. Equal comparison operator is 2 equality signs. Yes. So we're doing okay there, I think. So if side is 2 and roll is less than 2, then we're going to do that knockdown thing. Otherwise, if side is equal to 2 and roll is greater than or equal to 2, then we add 1 to the current sum and add 1 to the total roll. That should be correct. And then as long as side is greater than or equal to 2, that should have rolled for the 2's as well. That's weird. Nope. This didn't work either. It's alright. Alright, rolls down to 10. Rolls down to 8. Rolls down to 6. Rolls down to 4 immediately. Hey, look, we got a 2. I don't understand why it didn't do that before. Maybe it was just the and thing was throwing it. Oh, yeah, because if side is equal to 2, and it didn't parse any of the rest of it, if side was equal to 2, just subtract 2 from the sides. But it still wasn't rolling it, like, at all. That's weird. Oh, okay. It broke out of here and didn't print I or dsums for... No, that's not right. Because it would have done this first before it got to here. Right? No. If side is greater than 2, it would reduce it to 2, and then immediately jump into this one, lose the and then immediately subtract 2 as well. Oh. Ooh. So actually that means that we need this to be... Actually, that should be first then. This will work. Put this above that one. Right, that will not cause problems. There we go. It won't immediately roll into the other one and then potentially just end the program. Okay. Let's see it again. 12, 10. Yep, still not doing the other stuff, but 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay. I mean, it's there at least. Okay, so we've got one trial that's being done, and then it's just copying the rest of them into the rest of the trials and not doing anything. So that's not cool. So what other thing am I screwing up? Side doesn't reset. Yeah. Oh, yes. Yes. So that means that we also need this to be like sides, which is going to then reset here. It's bonkers. All right. Nice. We got it. I think. Yeah. Yep, okay. Yep. 611417. 7 rolls on the wow. 7 rolls on the two-sided die. I mean, it's just a coin flip, but still. 7 in a row is pretty great. Hey, we did it. Well, thanks for helping. So the first one's really 69 rolls? Or is it just the total? No. 20, 11, 31, 46. Yeah. 60, 72, 71, 91. Wait. 52. Ah. It's just adding to it again. Yep. All right. So we do need to put in zeros for. Yeah. Okay. So it's just adding the sum total of all of them into dsums. So yes, dsums actually does need to reset here. But that's easy. P dot 0 side over 2. Yep. All right, so 10, 10. Nice. All right, we got it. So 13, 9, 10, 11, 12, 13. Cool. 6. Oof. That one's ouch. Okay. So then if we do this for the proper 10, 100 trials, nice. We do the thing. All right, frequency graph. How does this work? Oh. Figure canvas ag is non-interactive, thus cannot be shown. Well, I don't know what that is. So it did actually. It ran it directly. Awesome. It's gonna be shown. Wait. No, that's alright. That wasn't what I was thinking it was going to be, but that's fine. Because it's not frequency per die size. That's just frequency of the number of rolls you're going to get. Yeah. Frequency of number of rolls. Literally what I just wrote underneath it. Okay. Okay, X bins. Range, density. What's density? I don't see density here, so... Oh, no, there it is. Jeez. Okay. Also known as hist2d. There's ag filter. Figure. Matplotlib.figure.figure instance. Okay. Figure canvas ag. Is non-interactive. What do you know? All right. Reinstalling matplotlib seems to have worked for some people. Installing pyqt6 appears to have worked for some people. use, yeah, that. See how much this is going to damage the program. Nope. Ouch. Gotcha. What do you mean mat plot lab is not defined? That's nonsense. Okay. Oh, so many problems. Nope, can't do it. Alright, well, it still works if we cut these two out and just leave it like that. It got us the data, which is really what I cared about for most of this. It's too bad it doesn't come up with the frequency plot, but well, anyway. I think now's about a good time to check out who else is online, and then we'll head on over there, and hope you all have a good day. We will be back tomorrow. We're going to be continuing our run on blueprints, and see what we got. Pokemon Sapphire on winning sequence. Looks like they're still in the same area. They are running they're running Pokemon Sapphire by using the digits of pi. So it's famished. You're lucky I didn't hit the button yet. Gabito and Actual Education are up. Dr. Gold's been on for 4 minutes. So we'll probably go over and see Dr. Gold. Alright, Famished, what do you want? Which one? Tai Chi, Eskrima, or Tangsudo? Oh dear. Tai Chi. You got it. Alright, and we might as well just put the music back on here while we're goodness. Alright, so yeah. That one. Oh, that is all off kilter. Awesome. Right, so as we start doing Tai Chi type stuff, I mean, realistically, I should do it no matter which one I'm doing. Want to warm up, make sure your joints are nice and loose. Anybody who wants to join on in, you can do that. You're just basically letting your arms swing a little bit, and then you push out or tuck into your inguinal crease right in the groin area, and then as you're coming out of it, you just push a bit, and it kind of whips both of your arms around. Oh my goodness, we're keeping the beat. Who knew that my natural harmonic frequency was the same as this song? Pretty close. Okay, and then once we get that, usually do a bit of side to side like this, and then just bring the knees into it a bit. Let the arms again swing pretty freely. And then just by doing this little pump, just like you would on a swing set, that's going to cause your arms to swing higher. And make sure they each get a turn, each one in front. Try to keep it symmetric, all that good stuff. And then we can go with the kind of Nordic skiing type thing here. Do want to try to keep our heads up as much as I like looking at the floor. I'm an outgoing mathematician. I look at your shoes. Right, swing up both at the same time. Uh-oh. Ads are gonna run. What? I got 2.5 minutes. Alright, we can do the form. Right. So, feet together, V shape. Tuck. Move. Straighten out. Go to this side. Come forward with the ward off. And we tuck here a bit, step back out that way, do a ward off this way, into a press, and push, lean back, come around, and then we go to here, single whip, come back this way, change direction, arms up, shoulder. That's too much of a step, but nonetheless, shoulder. And then from here we go to crane. That was me not turning my foot the right way. There we go. And then from here, oh man, he had me do one this weekend, and I don't remember what it was, or last Wednesday. No, I don't remember what it was. It's been a week. That's it. Oh, that's right. We go out, ah, damn. It's here, this one comes around, and nope, it's down, that's what it is. It's down, 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 strike. That's a tiger strike there. So, comes through and basically cracks in like that. Anyway, thanks for coming, everybody. We are going to go see Dr. Gold, and I hope you all go... Thank you. Hope you all stick around, hang out with Dr. Gold, do some math with him, and then we'll be back tomorrow for Blueprints. So, hope you all have a good night. My name's Obi-Wan Pez. This is In Simplex Pachinko. Have a good night.